Grade 12 learners, welcome to the Scienceless channel. In today's video, we'll be doing Mathematics Paper 2, February-March 2014 question paper. We'll go straight to question 5. Now, in this question, it reads as follows. They say here, in the diagram below, the equation of a circle with center M is, and they've given us this equation here. Now, in this equation, we can see that we have a circle that is not at the center because it is defined by the equation that is given by x plus or minus a all squared plus the y plus or minus b all squared is equals to r squared. This equation defines that circle that has moved from the origin. Now we can see here that this circle has moved to the right by 8 units and has moved downwards by 4 units. So this is to say our M here started being here, but it has moved here by 8 units and went down by 4 units, giving us the M there. Now this M here, it means it's defined by 8 and negative 4 because we're going in the negative direction with our 4. And not only that, we can also see here that our radius here, right? Remember the 45 here, already it's a square, right? That means if I take the root of 45, we get our radius as 3 root 5. So what I'm saying here now is that we have r here defined by 3 root 5. And we can see that from here to here is the center. From here to here is the center. It means also here, this is r. Right. The question continues to say PT here is a tangent to this circle at point T. And the same line PT is parallel to OM, right? So those two lines are parallel, hence we have those arrows there as well. Now they then go and say another circle having center O, so this circle here having center O, touches the circle having center M. It touches this circle here at the point N. Now, if you look at the circle that we are given, the second circle, we have this point here, this one to be 0, 0, because it is at the origin. And this means this circle here is given by the equation x squared plus y squared plus is equals to, so we have an equal sign here, is equal to r squared, right? Even though we don't know r, we can see here that our r is on, I mean to say, right? But we don't know it. So that's what's happening in this question. Not complicated. I think it's straightforward. Let's go try to answer questions. Now, question 5.1, they say write down the coordinates of M. So they need the coordinates of M, the center of that circle. Already we have written them here, right? So it's just a matter of now going to answer this question here, question 5.1. Now, I will answer this question slightly different, just to give you a tip in case these things, they get confusing or you don't know how to define the center. So the best way to answer this question, where you'll always get it right, is that you take this guy here, x minus 8, then you set him to 0. So you'll say x minus 8 is equals to 0, so that our x is equals to 8. Then you do the same for this guy here. You set y plus 4 to 0, right? So y plus 4 to 0, so that our y is equals to minus 4. Therefore, this means our M, the center, is given by 8, the x value, and y, negative 4, the y value, right? So this is the best alternative to go through if you are struggling to read it from the equation, because I know sometimes these positives here and the negative can be confusing for you guys. for some of you guys, right? So we're then going to do question 5.2 that says calculate the length OM. So where is OM? Let's look at that. So OM is from the center of the other circle to the center of this first circle, that is the center of M, OM, this distance here. Already I can see that I have my coordinates here, right, the O and the M. So this will simply be a question where we use the distance formula to find that length, right? And our question says leave your answer in the simplest set form. Already they're giving you a clue that you will use a square root along the way. So, you know, if the distance formula here should be used, we will say the distance OM is given by the root of x2 minus x1 all squared plus y2 minus y1 all squared. Now remember this formula, I think it's on your formula sheet. You can always go there, use this formula from the formula sheet. So here our x2 will be here at our m, and then this would be our y and x1. So we'll say 8 minus 0, right? So the 8 here minus the 0 here. Then we tap into the y, this is squared here. We have the negative 4 minus the 0 all squared, right? Now we then come and say we can use a calculator here, right? I don't think you need to waste time on this one. You can simply use a calculator. So you can see that we have a 8 0 all squared plus negative 4 0 all squared, and this gives us the decimal and the set one. So remember our question here, they will give you a mark if you leave it in the simplest set form, right? So it has to be set form, don't write it in decimal places. We then have question 5.3 that says calculate the length ON. Leave your answer again in the simplest set form. ON, where is ON? Look at this question. ON is only from here to here, is the radius of this other circle, right? You know, this one we can't use the distance formula because we don't know the point N, right? If we knew the coordinates here, we would use the distance formula again. So we don't know that. However, we know the distance from here to here, right? So I can say here on this question 5.3, I can say that the distance OM, right, is equals to, now look at this, very, very important. If you look at the distance from here to here, right, is the same as saying the distance from here, right? So ON plus the distance from here to here, NO. If you add the two, they'll give you this total distance here, right? So we're going to add ON plus NM to get that distance. So this will be ON plus NM. But it's very important to realize that NM, we talked about this when we were reading the question. NM is the radius, right? Is this guy here, the 3√5, right? So already we have the 3√5 here. We have the 3√5 here. And then ON is what we're looking for. We just calculated this guy here. So it becomes a simple substitution problem where we will say this guy here is 4√5. We just done him from the previous question. We are looking for this guy, and this guy here we're saying is the radius, which is given by 3√5. 3√5. Now, you know, here I will simply say therefore ON is equals to, I'll punch this on the calculator. So what I'll be doing, I'll be taking this guy to this side so that I have this minus this guy, right? Because this guy will be negative when it goes to that side. So here we will have a 4√5 minus 3√5, right? So this simply gives me a √5. This simply gives me a √5. It's the simplest set form as well. So that's our final answer there. We then jump to question 4.5 that says calculate the angle OMT, the angle M. So basically looking for the angle M. OMT. We're looking for this angle here. Right. Now, to be able to get this angle, you have to realize that this line is parallel to this line, right? So remember, parallel lines, they extend like that. And what this means is that the MT is a transversal, is a line that cuts between the parallel lines, right? These two parallel lines. And as a result, already you can see that we have an alternating angle, right? Meaning this angle is the same as this angle here, right? Now, this means if I found this angle here, I'll be able to find this angle here. And we know that this line is a tangent at the point T. So this means it makes an angle of 90 degrees here, right? If you know your theorems from Euclidean geometry, it becomes easy. So I'll come here and say the angle PTM, right? The angle PTM is equals to 90 degrees, right? So which angle is that? I'm saying the angle PTM, this angle here, PTM, right, is equals to 90 degrees. The reason is you have to give your reason, even if this is not Euclidean geometry, but you still have to give the reasons. They mark that. We know that the tangent is perpendicular to the radius, right? We know that the tangent is perpendicular. If you draw a tangent to a circle, right, that tangent will make a 90-degree angle with the radius. That is one of our theorems. But we just said that this angle here is the same as this angle because these two angles are alternating angles, because this MMT is a transversal. So that means now I can then conclude and say, therefore, angle PTM is the same as the angle that we are asked to calculate, which is OMT, right? OMT. But now remember, this is 90. It means this also will be 90 here, right? So this will be equals to 90 degrees. Now the reason being would be PT is parallel to OM. We were given this, right? So this will give me alternating angles. Alternating angles, yes, right? The PT here is parallel to MT, we were told in the question. So that's how you find your angle there. I hope that makes sense, or at least you are able to see it. So we'll continue with our question 5.5. It says determine the equation of MT in a form y is equals to mx plus c. MT. So MT is this line here, right? Now, if you look at this, we have a point here. So all we need is to get another point so that we can get the gradient, and then we are able to find that equation. But you'll realize that we don't know this point here. That's why this question becomes tricky now, because we get stuck in terms of finding the gradient and then using our equation of a straight line to define this equation. So we don't need that though, because we have like enough information to go through this. We just discovered that here we have a 90 degrees, meaning that this line here, MT, and this line OM are normal lines, right? Meaning they make an angle of 90 degrees. Remember, normal lines make an angle of 90 degrees. They are perpendicular to each other. And what do we know about normal lines, or lines that make an angle of 90 degrees with each other? We know that those lines, the product of their gradient is equals to -1. So that means if I find the gradient of this line, I can then multiply the gradient of this line and this line, equate it to put it to -1, and find the gradient of the second line, and therefore the equation, right? So I'll firstly start by finding the gradient of OM, right? So the gradient of OM would be given by MOM is equals to y2 minus y1, x2 minus x1, right? I'm going to use the same points that we're using here, if you remember them, the 8 and the 0, 0 there at the origin. So this will mean my y will be -4. Remember, I'm starting with y now, minus 0 on the origin. Then we'll have 8 minus 0, right? I see a -1/2 here, so I can say therefore MOM is equals to -1/2, yes, because the 2 goes twice here. In this case, the 2 goes once here, but on the 8 it goes twice, and then we have a negative. or you can use a calculator, that's fine. And I'm going to argue here to say, but we know that the gradient OM times the gradient MT, which is what we're looking for, must be equals to -1, because they make a 90-degree angle here. Right, so the gradient of this times the gradient of that should be equal to -1, right? But we know now that the gradient of OM is -12, so we'll have MT here is equals to -1. Now, if we multiply both sides here by a 2 and by a 2, the 2 and the 2 will cancel, so I'll multiply by -2, so that the negative also is removed. So here I'll be left with MT. But this side, when you have a -2, is going to be a +2, right? So here it means we're going to have MT is equals to a +2. At this stage, we have two options. We can use that option that says y minus y1 is equal to the gradient of MT, x minus x1, right? Now with this one, I'm going to use this point here, because remember, this point M is a point on this line, right? So I'm looking for the equation of this line, MT, right? So I'm going to use the point 8 and a -4, so that now my y will be given by a -4. So we'll have a -4 is equals to, here we just said is 2x, it will be -8. Now this will give me y plus 4 is equals to 2x minus 16. So y is equals to 2x. When we take this guy to this side, it's going to be -16, -4, right? -16, -4 gives me a 20. So this is my equation. Now you can also use y is equals to mx plus c. Use the same point, 8 and -4. This will come, no, this will come here. The gradient we know is 2. And the 4 will come here, and then you look for the C. You should get a C of 20, then you are done. You can also try using that equation as well. So I'll jump into question 5.6. They say calculate the coordinates of T. So T is a point where we have the tangent, right? Calculate the coordinates of T there. Now, one thing that you have to realize, and I think with this question, the other thing that you have to see is that you use information from the previous question to solve the questions at the bottom. One thing that you have to realize is that the line MT intersects, right? It intersects, it cuts here the circle, right, at point T. They cut each other. And what do we know about graphs that cut each other at the same point? Well, we know that the x value and the y value, the x value on the circle is the same as the x value on the line, and also the y value on the circle is the same as the y value on the line, meaning the two graphs are the same at that point, right? So that means I'm going to do simultaneous with those equations. I'm going to go to 5.6, and I'll say my equation x minus 8 squared plus y plus 4 squared is equals to 45. This will be equation 1, right? And then I'll then come and say the line MT is defined by the equation y is equals to 2x minus 20. So this is equation 2. But we just said now that the x value and the x value are the same here. The y value and the y value are the same here, because these two graphs intersect each other, right? So what I'm going to do, I'm going to calculate those x and y values. So that means you can see here the simplest equation to solve this is to do simultaneous, where we take this y and substitute here, right? Because it's going to be difficult for us to make x or y subject of the formula here. So it's easier to take this one here and solve for x, and then later on solve for y if we need to, right, to get the point, the y value on that equation. So here I'll come and say substitute equation 2 into equation 1, so that now we have x minus 8 squared plus y plus, no, so here is not going to be y, I'm not substituting now. So we'll have 2x, which is my y now, right? and then we have a plus 4, which is all squared is equals to 45. Right, so what have I done? I took the y here and substituted that with its y value in terms of the straight line mt, right? Then we can solve for x here. Now at this stage, this looks like paper 1 algebra, right? It's something that we all know. So remember that the trick that we do when we have a square like this, a binomial like this, we square the x, right? That's the first thing that we do. We square, okay, before I do that, maybe let me simplify this part here. Maybe let me simplify this part so that I do the same thing on all of them. So I'll keep this as is for now. I'll say x minus 8 squared plus. So in here, I can see that when I combine these two here, I get a negative 16. So this is 2x minus 16 all squared is equals to 45, right? Now, the first thing that we do is that we square this guy here. So it's going to be x squared. Then we take the 2, we multiply it by the x, we multiply by the 8 as well. So I have 2 times x, which is 2x, times negative 8, right? So that should give me negative 16, negative 16x. And then the last thing that we do is that we square the 8. Obviously, when you square 8, it's going to be a positive number, and it should be 64, right? Then we do the same routine here. We square this guy here. I can see that I'm going to have a 4 and the x squared, right? We take the 2, we say 2 times 2x, all right? That is 4x times negative 16, multiply by this negative 16 again, right? This should give me a 4 times negative 16, that's 64 again, right? So I get a negative 64x. Then the last thing that we do is that we square the negative 16. Obviously, squaring negative 16, okay, we can use a calculator. Let me try to use a calculator. 16 squared, it says it's a 256, right? So here we'll have plus 256. And what I can do also is that I can then take the 45, bring it this side, right? So that it becomes negative 45, and this side I'm having a 0, right? Because this thing you can see is going to be a binomial. It's going to be a quadratic sort of problem where we solve for x as a quadratic equation. So at this stage, what I will do is that I will start with my x squared and 4x squared here, right? When you combine those two, they'll give you a 5x squared. And then the next thing that I'm going to do is negative 16, negative 46. That should give you, I see a 0 here, 780, right? That's negative 80x. Then we now have the numbers, right? We have a 46 here. And okay, to save time, let me just use my calculator. This is 46 plus 256 minus 45, right? That gives me a 725. So we're going to have a positive 275 is equals to 0, right? Now, I think at this stage you can use a quadratic formula because I see we have big numbers, it's easier. Or the other thing that I see is that I can see a common factor of 5 here. So if I divide by 5 here and divide by 5 here, I can reduce this. Maybe it's something that I can work with. So if you divide by 5 here, if we divide by 5 here, we get a 5. We get an x squared, sorry, the 5 would cancel each other. And we know that the 5 goes 16 times into 80, right? I'm not sure how many times it goes into 275 divided by 5. It goes 55, right? So this will be plus 55 is equals to 0, right? This looks like something that I can work with because the products of 55 could be 11 and 5, So 11 times 5 would give me 55, right? And I can see that if I say 11 minus 11 minus 5, right, this will give me a negative 16. It's going to be a negative 16, yes. So which is this middle part here, right? And this is the product of the two. So my factors, when I factorize this, would be a negative 11 there and a negative 5, right? So this means that I'm going to have x is equals to 11 or x is equals to a 5. Now, we have to interpret these numbers, no? Remember on our diagram that we know that this point here is given by 8. We said this thing moved from, m moved from 0 to 8, and then it went down 4 units. So we know that the value of x here is 8, right? Now, look at our answers. If we have 11 and 5, you can see that the 5 is actually a point here. The 5 is a point here, and the 11 should be a point here, right? Because 5 is less than the 8, and the 11 is above the 8, right? Well, in fact, the 11 is not going to be here per se, because remember, this is an intersect. There's a point here. 11 is an intersect. It doesn't happen at 0. It happens when these two intersect. This line and this line intersect. These two graphs intersect. So it means our 11, our value of x here should be 11, right? So we will say here, but for t, x is equals to 11, right? So this is not our answer for this specific question that we're looking for. Now, to get a point t, it means we then have to go to this equation 2. Here, we put the value of 11, and we find the value of y, right? So at this stage, I'll come and say, substitute x into equation 2, so that we have y is equals to, it was 2x minus 20. So our x, we're saying it's 11 here, minus 20, right? I see 22 minus 20. 2, so here we have a 2 times 11 minus 20. That gives me a 2, right? So that gives me 2. This then means that the point t will be given by 11 and a 2, right? So this point here is 11 and a 2. That's the point we're looking for. I hope it makes sense. I hope it makes sense. This was a fun question. I enjoyed doing this question.